Hi, my name is Nogara Shafia binti Muhammad Hairul and my ID number is 012025020021, and currently I'm taking business mathematics, and right now I'm going to explain to you guys the arithmetic and geometric sequences. And for the first one, we're going to start with a arithmetic sequences. Arithmetic sequences is a list of numbers where the differences between each term and the one before is it always the same. This fixed number is called the common difference D. For example, in the sequences 2, 4, 6, 8, the common differences is 2. And arithmetic sequences are often used in real-life situations like calculating regular payments or evenly increasing patterns. And now, moving on to the arithmetic formula, there are formula to find the nth term, which is Tn equals to A plus, in bracket, n minus 1, and then you close the bracket back, D, where A represent the first term, D equals to common difference, and n the numbers of term. And the formula to find the sum of the first n term is Sn equals to n divided by 2, open bracket, 2a plus n minus 1, and then d, and you close the bracket back, or we can use other formula, which is Sn equals to n divided by 2, in bracket, a plus l, and then you close the bracket back, and in this formula L represent the last term. And right now we're gonna move on to the question 1 of arithmetic sequences, which is in the year 2000, a shop sold 150 tablets. Each year the shop sold 10 more tablets than a year before, so that the shop sold 160 tablets in 2001, 170 tablets in 2002, and so on, forming an arithmetic sequences. And for question A, they asked to show that the shop sold 220 tablets in 2007, and to find any term in arithmetic sequences, we use the formula an equals to a1 plus n minus 1d, where an is the term we want to find, a1 is the first term, n is the term number, and d is the common difference. And for this question, in the year 2000s, the shop sold 150 tablets, and each year they sold 10 more than the previous years. And to find out how many tablets they sold in 2007, we know that the first term A1 is 150, which is the tablet that they sold in 2000. And the common difference D is 10, since it increased in sales for each year, and the term numbers N is 8, since 2007 is the 8th year from 2000s. And we're going to substitute all of this value into the formula, and we're going to get A8 equals to 150 plus 8 minus 1, 10. And then we're going to simplify the equation, and then we're going to get A8 equals to 150 plus 70, 10. And then we're going to calculate all of the numbers, and the final answer is 2020. And therefore, the shop sold 220 tablets in 2007. And for the second question B, the question asks to calculate the total numbers of tablets the shop sold from 2000 to 2013 inclusive. And for these questions, to calculate the total number of tablets that they sold, we need to find the sum of the arithmetic sequences. And the formula for this question is given by Sn equals to n divided by 2, in brackets, 2a plus n minus 1, d, and then close the bracket back. And first, we need to identify the numbers of years from 2000 to 2013, which is 14 years, so n equals to 14. And we know the first term A represent the sales in 2000, which is 150, and the common difference D is the annual increase in sales, which is 10. And we have to substitute all of this value into the formula, so we get S14 equals to 14 divided by 2, in bracket, 2, 150 plus 14 minus 1, and then 10, and then close the bracket back. And we have to simplify these questions, and 14 divided by 2, we're going to get 7, and inside the brackets, 2 times 150 equals 300, and 14 minus 1 times 10 equals 13 times 10, which is the final answer is 113. So the equation is S14 equals to 7, in bracket, 300 plus 113 and then close the bracket back. And by adding the value inside the bracket, it gives S14 equals to 7 times 430. And finally, we have to calculate all of this value, and we're gonna get 3010. Therefore, the shop sold a total of 3010 tablets from year 2000 to 2030 inclusive. And for the last question, C, in the year 2000, the selling price of each tablet was 900 ringgit, and the selling price fell by 20 ringgit each year, so that in 2001, the selling price was 880, in 2000, the selling price was 860, and so on, forming an arithmetic sequences. And the question is, in a particular year, the selling price of each tablet in RM was equal to 3 times the numbers of the tablets the shop sold in that year. And by forming and solving an equation, find the year in which this occurred. And this problem introduced a new arithmetic sequences related to the selling price of each tablet. And in the year 2000, the selling price was 900 ringgit, and it fell by 20 ringgit with each year. This means the first term of this price sequences is 900 ringgit, and the common difference is negative 20. We are also given information about the numbers of tablets sold, which we know that the sequences started with 150 in 2000 and increased by 10 in each year. And the problem also states that in a particular year, the selling price of each tablet in ringgit was equal to 3 times the numbers of tablets the shop sold in that year. And to find this year, we need to set up an equation. And we're gonna let n represent these numbers of year after 2000s. And the selling price in the year can be expressed as 900 plus n minus 1 and negative 20. And the number of tablets sold in that year is 150 plus n minus 1, 10. And according to the problem, the selling price equals 3 times the numbers of tablets sold. So we can write the equation as 900 plus n minus 1, negative 20 equals to 3, 150 plus n minus 1, 10. And we're going to expand all of this equation, and it's going to give us 900 minus 20n plus 20 equals to 3, and then in bracket 150 plus 10n minus 10, which simplify us to 920 minus 20n equals to 3, 140 plus 10n, and further to 920 minus 20n equals to 420 plus 30n. And rearrange the term to solve for n, we get 920 minus 420 equals to 30n plus 20n, which simplify to 500 equals to 50n. And divide both sides by 50, give n equals to 10. Since n represent the number of year up to 2000s, the year in which they occur is 2000 plus 10, and the final answer is 2010. So we know that n equals to 10 and the year is 2010.
Hello guys, my name is Wabiro Faris. So we move the next question, which is my question. It sounds like Samsung is making 200 mobile phones. Each week plan to increase its production. The number of mobile phones produced is to be increased by 20 each week, from 200 in week 1 to 220 in week 2 to 250 in week 3, and so on until it is producing 600 in week n. So we must find the week n. So let's solve the part A, finding the value of n. The company plans to increase mobile phone production every week, starting from 200 phones and increasing by 20 each week until they reach 600 phones in week. We notice the pattern 200, 2000, 220, 240 and so on up to 1600. This is arithmetic sequence, and we use the formula. The A is the 200, second D is the 20, and third AM is the 600. Let's use the sum formula for the arithmetic sequence. For example, this. So we move the second question, which is the part B. We need to find the total number of mobile phones produced in the first 52 weeks, starting from week 1. We already know that for the first 21 weeks, production increased by 20 each week, forming an arithmetic sequence. After that, from week 22 to week 52, the company produced 600 phones per week. To calculate the total, we split it into the two parts. So for the first 21 weeks, S equal 21, dividing 2, multiply in the bracket 200 plus 600 equal 8,400. Then for the remaining 31 weeks, 600 multiply 31 equals 18,600. Bars 8,400 plus 18,600 equal 27,000. So the total number of mobile phones made in 52 weeks is the 27,000.
And for the second sequences is geometric sequences. So a geometric sequences is a list of numbers where each term is found by multiplying the previous term by a fixed numbers called the common ratio R. For example, in this sequence, 3, 6, 12, 24, each number is multiplied by 2 to get the next term. And geometric sequences are commonly seen in population growth, investment, and scientific patterns.
Hello, my name is Naridiana Izaidi and my ID number is 0122025020036, and I'm also a student of this class, which is Business Mathematics. And now I'll be going to the first question for geometry quiz, which is Mono Trading predicts a yearly profit of 120,000 ringgit in the year 2013. The company predicts that the yearly profit will rise each year by 5%, and the predicted yearly profit forms a geometric sequence with a common ratio of 1.05. So for the first question under this main question is show that the predicted profit in the year 2016 is 138,915 ringgit. So for this question, we use the formula to find the nth term, and for this one, we want to find the fourth term, which is D4. So our A is 120,000, our R is 1.05 as stated in the question, and our N will be 4, which is from 2013 to 2016, which is 4 years. So for the predicted profit, which is D4, equals to 120,000 times by 1.05, and with the power of 4 minus 1, and we will get the solution until we get the number 138,915 ringgit. So that is our predicted profit for the year 2016. So now we are going to move on to the second question under the main question, which is the value of the car falls below 1,000 ringgit for the first time in N years after it was purchased. So based on this question, we would like to find the value of N. We have our A, which is 18,000. We have our R, which is 0.8, and we don't know what our N is. So we are going to solve based on the earlier question from before, which is 1800,000 times 0.8 to the power of N less than 1,000, because it says falls below 1,000 ringgit, and then 0.8N less than 1,000. The 18,000 moves to the other side, which will be over 18,000. 0.8N less than 0.05, and then we will be going to log both of the sides because the n, we don't have the power of the n, so log 0.8n less than log 0.05, and then we'll move the n to the front, which will be n log 0.8 less than log 0.05, and then we'll be searching for the n, which is n less than log 0.05 over log 0.8, n less than 13.425, and we'll get n equals to 12 years because it wants less than 13 years. So n equals to 12 years. So for the next question, which is our C question, we need to find the total predicted profit for the years 2013 to 2023 inclusively, giving our answer to the nearest million ringgit. So based on the question earlier, our A will be 120,000, our R will be 1.05, and our N will be 11, as 2013 to 2023 is a total of 11 years. So from this sequence, we can see that we are calculating from 2013, 2014, all the way up to 2023. So we will use the formula of sum of n terms. So based on this formula, we are going to choose r is more than 1 since our r is 1.05. So our total profit, we will label it as S11. S11 equals to 120,000 in bracket 1.05 to the power of 11 minus 1 over 1.05 minus 1. So based on this formula, we already substitute the numbers into it, and then we will calculate and get 1704814.459 ringgit, which will round it off to the nearest major ringgit, and we will get RM 1704814 ringgit as our answer. So now I will be moving on to the next question, which is question 2 for geometric sequence. So for our question 2, it stated that a car was purchased for 18,000 ringgit on 1st January, and on 1st January each following year, the value of the car is 80% of its value on 1st January in the previous year. So now I'm going to move on to the first question from this main question, which is show that the value of the car exactly 3 years after it was purchased is 9,260 ringgit. So based on this question, it wants us to prove that our answer will match with the answer given in the question. So for this question, we are going to use the formula Tn, which is we are going to find the nth term. So Tn equals to AR to the power of 9 minus 1. So based on the question, we have our A and our R, which is A equals to 18,000, R equals to 0.8, and our N equals to 4 because it says 3 years exactly after. So 3 plus 1 equals to 4 years. So T4 equals to 18,000 times with 0.8 with the power of 4 minus 1, and then we will solve the calculations and we will get T4, which is 9,260 ringgit. So now we are going to move on to the second question under the main question, which is the value of the car falls below 1,000 ringgit for the first time in n years after it was purchased. So based on this question, we would like to find the value of n. We have our A, which is 18,000. We have our R, which is 0.8, and we don't know what our N is. So we are going to solve based on the earlier question from before, which is 1,800,000 times 0.8 in the power of N less than 1,000 because it says falls below 1,000 ringgit, and then 0.8N less than 1,000. The 18,000 moves to the other side, which will be over 18,000. 0.8N less than 0.05, and then we will be going to log both of the sides because the n, we don't have the power of the n, so log 0.8n less than log 0.05, and then we'll move the n to the front, which will be n log 0.8 less than log 0.05, and then now we'll be searching for the n, which is n less than log 0.05 over log 0.8, n less than 13.425, and we'll get n equals to 12 years because it wants less than 13 years. So n equals to 12 years. So now we'll be moving on to the third question under this question, which is an insurance company has a scheme to cover the maintenance of the car. The cost is 200 ringgit for the first year, and for every following year, the cost increases by 12%. So that for the third year, the cost of the scheme is 250 ringgit 88 cents. So find the cost of the scheme for the fifth year, giving our answer to the nearest major ringgit. So from based on this question, our 12% would be 1.12 since it says increase. So our sequence is 200, and then the second term, and then the third term, which is 250.88, and so on. So our R will be 1.12. Our second term will be 200 times 1.12 since this is a geometric sequence, so we will have to times it, and then we'll have 224 as our second term. So our A will be 200, our R will be 1.12, and our N will be 5 since it says for the fifth year. So we will use the formula to find the nth term, which is Tn equals to AR with the power of n minus 1. So T5 equals to 200 times 1.12 with the power of 5 over 1. 5 minus 1, sorry. And T5 equals to 200 in brackets, which is times 1.12 with the power of 4. And we will have to solve it to 314.703872, which we will round off to the nearest ringgit, which will get 340 ringgit and 70 cents. And now we'll be moving on to the last question for this main question, which is D. Find the total cost of the insurance scheme for the first 15 years. So we want to find the total cost. We're going to use the formula of sum of n term. And since our R is 1.12, we are going to use the formula if R is more than 1, as n equals to A in brackets Rn minus 1 over R minus 1 and close the brackets. So our A will be 200, our R will be 1.12, and our n will be 15, since it says first 15 years. So the total cost for 15 years, we'll label this as S15. S15 equals to 200 times with 1.12 with the power of 15 minus 1 over 1.12 minus 1, and we will get 7,455 ringgit, 942,932 cents, and then we will round it off to the nearest ringgit, which will get 7,455 ringgit and 94 cents. And that is all for our geometric sequence questions.
For the conclusion, arithmetic and geometric sequence are fundamental concepts in mathematics used to describe pattern of numbers. An arithmetic sequence increase and or decrease by a constant difference, making it ideal for modeling linear growth or decay. In contrast, a geometric sequence changed by a constant ratio, making it suitable for exponential growth or decay. Understanding the sequence helps in solving real-world problems involving finance, population growth, and more.